Very good. Okay, so today's going to be pretty similar to yesterday, except I'm not going to teach it over two parts. I'm just going to teach it over one part. We're looking at the third form of a quadratic, right? I've said there's three ways we can express a quadratic. We're familiar with general form, right? Ax squared plus bx plus c. And what does it tell us? The y-intercept. The y-intercept is c. That's where it crosses the y-axis. Yesterday we learned about axis-intercept form. Okay, we can achieve that by factorising it, and it tells us the roots. It tells you where it crosses the x-axis. And the last way we can represent it is by completing the square. We call it completed square form. It's going to look like this, and it tells you the coordinates of the vertex, right? That maximum or minimum. Okay, they have coordinates hk. One other property, if A is positive, that number out front is positive, we expect it to open upwards. It's a happy face. If A is negative, it's going to be a sad face. So we're going to start with one that's already completed for us, all right? And we're going to graph it. And then in the second example, we need to complete the square. So for example A here, we've got y equals x take 1 squared take 4. And the first part says, determine the coordinates of the vertex. Well, let's compare what I've got written here with what's up here. All right. Firstly, the value of A is positive 1. Okay, the value of A is positive 1, which means it's going to open upwards. Now, I'm going to make a bit of a list like we did yesterday. I'm going to make a list of all the information that we need. The vertex, the roots, the y-intercept, so that we can put all of that on a graph. So we've got A opens up, we can make that as part of it. We've got A is 1, therefore the shape is going to be a happy face, it's positive, it's opening upwards. Okay, now when we're comparing these, I'm going, what corresponds with H and what corresponds with K? And so we can see the number 1 corresponds with H. H is positive 1, all right? Because we have the negative there and the negative there. So if we look at what's in the same position as H, it's 1. Okay, so we've got H is 1. The value of K though, over here we've got plus K, and we've got that corresponds with minus 4. So that means the Y value is minus 4. So we've got the coordinates of the vertex, and we can see that just from looking at the quadratic in the completed square form. So the coordinates of our local minimum are going to be x is 1, y is minus 4. Okay, part 2 says, state the equation of the axis of symmetry. So remember yesterday, when we had those graphs of the quadratics, this vertex here was the axis of symmetry. All right, you might remember these two equations, p plus q on 2, or minus b on 2a. They tell you the x value of the middle, which also corresponds with the x value of the vertex. So in order to answer part 2, we're just going to say, what's the x value here? 1. So the axis of symmetry is x equals 1. All right, so I'll say all that again. The vertex and the axis of symmetry have the same x value. Yesterday when we were doing it, we found the axis of symmetry and we used that x value, put it into the original function to determine the corresponding y value, right? Today we're starting with the vertex, and so we're saying what's the axis of symmetry? It's just going to be that x value. Okay, so pretty okay so far. Part 3, find the axis intercepts. Now, it hasn't specified which axis intercepts, and so that means we need to find all of them. So it's going to intersect the y-axis, and it's going to intersect the x-axis somewhere. So firstly, let's do the y-intercept. Just like yesterday, y-intercept occurs when x is 0. All right, when x is 0. So I'm going to put x is 0 into my equation here. I'm going to put x is 0 in there. I'm going to have y equals 0 take 1 squared, take 4. All right, all I've done is move the number x is 0 into the equation, and I'll evaluate this slowly. We've got minus 1 squared, take 4. Minus 1 squared is positive 1. right, so we've got the y-intercept is minus 3. Okay, next we need the x-intercept. Well, x-intercepts occur when y is 0. All right, so all we're doing, we're taking the equation, we're putting 0 where the y is. What we'll have, x take 1 squared take 4 equals 0. Y is 0. And now we're solving this equation. And we've done, again, this is a skill, right? Where we're bringing together all this stuff we've done before. If we're going to solve an equation like this, we need to break it down. First, we're going to plus 4 to both sides. So we'll have x take 1 squared equals 4. Next, we will square root both sides. Very good, Charles. So I'm going to write, I'm just going to write it up like this. The square root of 4 is plus or minus 2. All right? I don't need my brackets there, do I? You can keep them, it doesn't really matter. And then we're going to plus 1 to both sides. All right, so 1 plus or minus 2. So that's 1 plus 2 or 1 minus 2. So, how do we find the x-intercepts? Well, we make y equal to 0, and then we solve the equation. We break it down to get x by itself. These are the roots. Any questions about that? Very good. So we've got all the information we need, don't we? We've got the vertexes, x is 1, y is minus 4. We've got the roots, x is 3 and minus 1. And we've got the y-intercept. So we're ready to put all of that information on a graph. So we've got y-intercept of minus 3. I'm going to put that there. We've got the vertex at x is 1, y is minus 4. We're going to put that there. And then we've got roots at positive 3. So if I go 1, 2, 3 there, and minus 1 there. So it's looking like this. I'll move that a little bit there. Okay, so root at minus 1, root at positive 3, vertex at 1 minus 4, y-intercept at minus 3. Okay, so this is probably a good time to mention, like in a test, when you're graphing and you really want to get full marks for the graph, there's a couple of things we look for. It's not just the shape. We don't just want you to get the shape right. You need to get these locations correct, okay? They must go through those points. You need to label the axes, x and y, and you need to have a scale, all right? Now this here is a suitable scale, right? Because I've notated, yep, that's minus 1, that's 1 unit, another unit, right? You can't just not have anything written there, okay? And because it will be on grid, the scale that you put right there on the grid should match the diagram. All right, so that's a graph of the quadratic, and it has all the properties we would expect, right? It opens upwards, okay, because it has that positive a value. So pretty similar to what we're doing yesterday, right? We're going through, we identify the vertex, we identify the roots, the y-intercept, and that's all the information. I said the axis of symmetry is x equals 1. Okay, x equals 1 is that line. You can see it's symmetric about that line. Let's move on to the next one. So here we have x squared take 6x plus 5. We have a quadratic in general form. Now we could solve this using the methods we learned yesterday, right? We could factorize it and find the roots and do it that way. That would be an acceptable way to do it, except here we're trying to develop competency in the skill of graphing by completing the square. So here we're looking at a particular technique. So what we need to do with this quadratic is complete the square. And we're going to do it a little bit differently from the way we did it when we were solving equations by completing the square. Because when we were solving equations, we had it equal to 0 straight away. We're not going to have it equal to 0. In fact, we're just going to complete this square as it is. All right? So the first thing I'm going to do is just rewrite what we've got, except I'm going to put this plus 5 over here. All right, I'm just going to leave a bit of space so I can add some stuff in. Now, when we complete the square, all right, what do? We add b divided by 2 squared to both sides. That's how we complete the square, right? So here, I'm going to add 6 divided by 2 squared, all right? But because we don't have it equal to 0, it's not something we're doing to both sides, I've added it, and now I'm going to subtract it. And this is still the same as this. All right, it's like saying 5 is equal to 5 plus 3, take 3. All right, that's all I'm doing there. This expression is equal to this expression plus that term, take it away. We've maintained equality, legitimate operation. Because then this part is the completed square. This part's the perfect square. So I'll illustrate that. We're going to have x squared take 6x plus 3 squared. Alright, so I'm going to do it in lots of steps. And I will write it out like this, although this isn't a necessary component. 2 times x times 3. So all I'm showing you here, a squared, take 2ab plus b squared. We've set it up, whenever we add the b on 2 squared, that allows us to complete the square. And so this part completes to x take 3 squared. All right, and then we have this plus 5 take away 9 gives you minus 4 hanging out there, right? So what did I do there? We've added b on 2 squared, and because we added it, we had to subtract it to maintain the equality flowing down. Okay, it's still the same equation. Now it's completed, and we can go through and answer all of these things we did over here. So we'll start with the vertex. Okay, remember the vertex is HK. So what corresponds with H in this circumstance? Positive 3. What corresponds with K? Minus 4. Alright, so that's the coordinates of our vertex. We've got A is positive 1, so it's going to open upwards again. We have it opening upwards again. Here's our vertex. Okay, so let's find the y-intercept then. So when you go to find the y-intercept, you don't need to write out 0 take 3 squared, because you know 0 take 3 is going to simplify to minus 3 squared, right? So this becomes 9 take 4, which is positive 5. Okay, for the roots, the x-intercepts when y is 0. So we take the equation and we make it equal to 0. Move the 4 over. Square root both sides. And then move the 3 over. And we've got everything we need, right? We've got vertex, we've got roots, and we've got y-intercept. We're ready to plot all of that on the Cartesian plane. There was one part I didn't answer, wasn't it? It says, what's the axis of symmetry? The axis of symmetry, so this is to answer part 2. X equals the x value of the vertex, 3. All right, so I'm going to sketch that one next to this one. So this is the graph of example B. And we have roots at x is 1 and x is 5. We have a vertex at x is 3 and minus 4. And we have a y-intercept of positive 5. And the other thing we do, so I sort of got halfway through explaining how we get full marks for a graph. I said we need a scale, 3, 4, 5, but we also need to label the graph. And so when I say label the graph, it means we need a title of it. What is this graph? It is the graph of x squared take 6, x take 5, plus 5, or in completed square form, x take 3 squared take 4. Either of those is perfect because they're both different ways of talking about the same quadratic, right? It's the same function represented in different ways, all right? So we just need a label of it. Okay, so a fair bit going on there, but similar skill. We've got one more example, which we're going to start with a graph, and then derive the equation from it. So our graph looks like this: 0 minus 4. Cool, that's all the information we need. And so, when we're finding the equation of a graph in completed square form, we start with this, right? A times x take h squared plus k. That's what we start with. And we go, well, what are the coordinates of the vertex? The vertex here is -2, -4. And so remember the vertex is hk, right? The vertex is hk. So, what does h correspond with? -2. What does k correspond with? -4. So always x take h squared. H this time corresponds with -2. So we have x take -2 squared. And when we simplify that, it's going to be x plus 2. And like, can I just make a connection here, okay? Maybe you remember when we were talking about 3f. If we have x plus, what was the letter we used? We used c. If we have x plus c, it moves at c units to the left. If we have x take c, it moves at c units to the right. Here in brackets we have x plus 2. And what do we notice? At that minimum point is 2 units to the left. So that's just an extra connection to make. The d value, it's moved down 4 units. Alright, so back from exercise 3. Okay, so we've got this, but we're not done. We need to determine the value of a. And in order to find a, we can use any of the pieces of information we haven't already used. We've used this one, so we're not going to use that. That's not going to give us anything. So we can use this point, x is 0, y is 0, or this point, x is -4, y is 0. This one's easy, like 0 is really easy to deal with. So we know when x is 0, y is 0. It passes through that point, right? And so I'm going to put both of those into this equation to determine the value of a. So we'll put in 0 where the y is, 0 where the x is. Alright, to solve this, we're going to add 4 to both sides. So we'll have 4 equals 4a, a is 1. So therefore, alright, now we might just do one more thing here, okay? So at the moment, this is a completed square, right? We have 3 ways we can express a quadratic. This is a completed square. Another way we could express it is in general form. And another way we can express it is factorized. I'm going to do all 3 to try and point out some relationships here. So firstly, if we want to put it in general form, you just have to expand it, all right? So this is a perfect square, and so I'm going to expand that first. I'm just focusing on the brackets. That becomes x squared plus 2 times a times b plus 4x plus 4. Okay, so when we expand the brackets, that's what it expands to. and so it collects to this, x squared plus 4x, because we have 4 take away 4. So if we were to look at this, this is now the equation in general form, right? We have A, we have B. Ooh, what's the value of C? There's no C there. What is it?
1, 0.
It's 0. The value of, oh, so Charles, C here we have 4 take 4. C is 0. What's the y-intercept? 0. What's general form tell us? The y-intercept here, the value of C is 0, the y-intercept is 0. So we can see if you expand the completed square, you can get the general form. If you're to complete the square, you can go back to general form. Okay, one more. We can factorize this. Now we're not going to use cross method here. We could factorize it like this, x times x plus 4. Okay. Or I might even write it like this, just for the sake of argument. X take 0 times x take minus 4. Remember, the way we write it as roots is x take p times x take q. What are the roots? P and q. What are the roots here? 0 and minus 4. Okay, so 3 different ways of writing the same quadratic equation. Alright, so that's just a little bit extra. For this question, right, you're getting full marks here when you've stated the answer. Just for pointing out some more connections. Because quadratics is a unit that's all about connections. It's all about the different forms and the way they're related to one another. So what we're doing today, you're going to start with some, like our first example, that are already completed for you. Go through, find those things, put them on the cartesian plane, and then you'll get some that are in general form, and you need to complete the square, right? So you add the b on 2 squared term, and then subtract it, maintain that equality. Cool, let's get started.